Start recording. Welcome to this course, Decision Support Systems. And inshallah, we'll start things formally today. Let me share the screen. So let us start with some, some formalities. My name, my email address and everything. And I will inshallah hopefully be coordinating well this time around as well. The course is inshallah, it will be interesting. I just wanted to make sure you understand its relevance to you, and relevance to your, as you are MIS plus your business as well. So you need to understand the relevance of the course in both perspectives. So I've highlighted few things in the course objective, which I've uploaded there, so that you understand why are we taking this course. And it's again, hopefully we'll try to convert this course into something meaningful for you. First of all, let me just remove this from the screen for a second. And let me ask you a question. But before that, if you could just drop me a word or two in the chat box, please. The rest of you, I've heard I've heard from few of you, but the rest. Okay, Lama is here, Shahad is here. I think before it was Fatima. Rest, if you could just drop a word or two. So Layla is here, Sukaina is here, Dulwa, Ajda, Athir, everyone welcome. So let me ask you a question. So Zahara, Huda, everyone, I'm keeping an eye on your on the chat box as well. So welcome everyone. So first question, if you could describe one of the most important thing in making a business a success, in making your, if you're working for someone, and if you could describe one key element to make business a success, how would you, I mean, what would you say? What is the most important thing to make a business success? Yes, Deemer.
Clear business goals.
Okay, goals. Else, anyone else? I want contributions from all of them. Okay, human needs. Human needs. Lulva says human needs. Dima says goals. Okay, good plan. Okay.
Decision making.
Yes, decision making. So while goals are important and plans are important, but these are all I'm talking about taking action, the action part, not the passive part. Passive part means somebody gives it to you, the customer needs and so on. So one keyword's fine, they are all important, but wherever you go, one of the key elements in making anything success is making the right decisions. So I want you to go even one level up. Plans are important, understanding human needs, customer needs are important, but even above that, if you try to bring yourself even above those things, they're all rooted in making the right decisions. So decision is something very, very important. And so this course discusses concepts, issues, and tools in what? In business decision making. So we are talking about something that is essential for all businesses. And no matter what you do, if you have enough resources, if you have even good goals, like Dima said, and you have good plan, but you are not making the right decisions at the right time, then eventually it will lead to, if not failure, lowering of business success. Okay, so decision is at the heart of everything, and decision is at the heart of this course. Now, although it's just a single word, decision, but it's like a whole world in the sense of, if you really wanted to make top quality business decisions, there are full sciences being evolved around that word, something called business analytics, decision sciences, data analytics, and business intelligence, and this course, decision support system. They all have one theme in common. They are trying to help businesses make what? Make good decisions. Okay. I hope you're all getting this point. So I'm just trying to emphasize the role of good decision making. So this course as you can imagine, what I said, because there are whole fields evolving around making good decision making. So just one course it will not be sufficient to have all the tools and techniques needed with you. So this is a big area, but still we'd like to make substantial move forward. We'd still like to have few things with us that will help us make good business decisions. Okay, so it dwells into some vital decision modeling. So one of the terms you'll see is called decision modeling. So one of the things we'll see even in today's lecture is decisions can be made in different ways. One way uh, is, let me give floor to you and ask you, how do you make decisions, coming, for example, from home to some place, you must be using something, right? So can you think of few ways that you employ in making a decision? Yes, Lama.
Yes. So first, I will collect resources or information, maybe through Google research.
Okay, so, okay, that's a good one. Anyone else? Anyone else would like to add other than Lama?
After I collect the data, I filter it to get the most important decision I have to get.
Okay, I see what you're saying. So I think, we need to broaden up our views a lot. So you're all trying to guess. Let's make life simple. Okay, let's start all over again. If I use my common sense, isn't it, Sukena? What were you saying, Sukena?
I was going to add something.
Yes, add it, Sukena. You're more than welcome to add.
I'll decide about the time and the cost.
You're going into fine, but I can summarize all three of you what you're saying. First way to make decision is by using common sense. I'll just use my common sense to make a decision. Another way is just randomly I pick and choose. Don't you all agree? Isn't it a way of to make a decision? I randomly decide, or I use my common sense, or I use my experience based on that. Do you all agree that these are all ways to make decisions? What you are trying to suggest, all three of you, and I guess the rest of you, is what you call more formal. Yes, my existing knowledge. So this is more what you call more formal ways of making decisions, right? So what if I can use a word or two, to describe what all three or four of you are saying, and I guess others are thinking on the same line, is to do some analysis, right? Is to do some sort of work before making the decision. Now that is where you're going towards what you call formal decision making, right? So when we say decision modeling, the word modeling, we are looking at more formal decision making, something where we don't take decision just like that, but like what you are saying, we'll collect data, we'll collect information, we'll talk about the cost and the time and use existing knowledge, and then we'll try to reach good decision. But before even that, let me go one step back behind decision. If you have only one choice, is there a decision in front of you? When do you actually can make a decision? Yeah, so
when I have
yes, Lama.
when I have a few choices, I have to choose between them. But when I have one, this is the only option.
Yeah, so you just have to remember that decision problem arises when you have multiple options to choose from. Okay, and in a typical business problem, just take a random guess how many potential choices you can have in front of you in a business decision making. Just, I know it's a lame question, but just take a guess. I want you to broaden up your mind, so I'm asking 5, 10, 15, 20. Just to give me a random number. It's fine. Yeah, okay, 10. Lama says 10. I want others to participate as well. I'm just trying to. Okay, 5. Sukena 7. This is a very, very small number where more than 2, okay. So fine, this is the minimum Dima. When you say more than 2, of course, that's where minimum decision is involved, because if it's one choice, there is no decision left, right? Lama says 50, so she's, I think, guessing where I'm taking her. It could be in thousands at occasion. So when it is in thousands, then do you see that there's a big problem in front of you, because you have to choose not from 2 or 5 or 7 as you're thinking. There can be situations where you only have 5 and 7, but think of what we do here in CBA. We assign classes to different times, right? How many we are offering 200 sections with potential hundreds of slots, and we have to choose. So many combinations are out there. We have to choose so that it becomes, of course, good for students and faculty both, right? So the decision, the options could be in many situations. A lot of situations, the number is, if it is in hundreds, if not thousands, and if not hundreds of thousands, and even more, many situations. And you'll be able to visualize this, so many choices, inshallah, very soon as we go along. Why am I saying that there could be so many choices? Okay, inshallah, it will broaden your imagination up. But you all understand what I'm saying. Decision, first of all, decision is something that is important for your business. If you make the right decision, you'll make more profit. Simple as that, right? So if I have 50,000 options in front of me, which one I need to pick? Because there may be one of them which gives me maximum profit or minimum cost, whatever, right? So it seems like a tedious job, right? To find that one out of so many. Do you all agree with that? You all agree with that? That, now here it comes more tricky situation. So these kinds of scenarios, yeah, tools will help. You can see that common sense and, random guesses and a little bit of experience, they can lead you to somewhere, but in many cases, you're far from the best, okay? So the real idea is to make decisions, formal decisions, and trying to reach, as call it as higher quality decision as possible. So this is the objective of the course. We are trying to learn concepts, tools, issues in making formal business decision making via, a formal method. We'll call it decision modeling. And these are like some ways to address the problem of dealing with so many choices. And then, inshallah, and again, it's a big field, so we'll be learning very few subset of these things. But if you're keen, you can take this as a field. You can learn, you can go to business analytics and, some of those other areas where you become expert. My area is actually decision modeling. So that's actually precisely the area. The things we'll learn is not precisely the area I normally work with, but it is part of what I do in my normal research and everything. So the students are required to demonstrate the application of these decision modeling techniques. So just like programming course, I'll not let you leave without pushing you hard. Sorry. No, I know you'll be excited. It is not meant to put you under pressure, but inshallah it will be fun. So we'll learn those techniques, and through projects or through a real project, you'll be applying those techniques, and you can see actually the difference before and after. Okay, and so unlike programming project where you spend a lot of time on computers writing long codes, here what you will be doing, you'll be trying to reach out to businesses and finding a real problem, and then using these modeling techniques to do whatever we learn in the course and try to improve their systems, trying to show that, by using those techniques, you'll be able to improve their performance. And improve their performance, it could be in terms of so many things, right? Like cost and profit and so on. So inshallah, we'll be looking at that. Now, in terms of course contents, there are mainly two, or let me say three parts. One is the general part. We'll get rid of that general part maybe in today's lecture. Okay, general discussions which will set up the base for everything. And because the course is called DSS, let me talk about that a little bit later. But two of the techniques, modeling techniques that we'll be employing that are useful in particular scenarios, we'll inshallah learn that. One of them is called clustering analysis, which comes from the family of those artificial intelligence and machine learning. So normally you'll be needing software, we'll be using software, but before that we'll do few things by hand to understand, to get it, conceptually understand it. And then inshallah we'll be using some very nice software which will allow us to do what you call clustering analysis. And then we have something very exciting here, which is called simulation. Inshallah we'll be learning simulation, and there's a software called Arena. We'll be inshallah using Arena. Let me see if I can give you a very quick flavor for that. No, I'll see. Perhaps I'll leave it lab file. Let me see if I have that. Okay, let me see if Arena wakes up. So by the time it wakes up, let me just talk about some of the other things. The book, it says, Arena is in front of us, so let me just take it away. The book says it gives you a book. The book for clustering, you don't need any book for clustering. The actual books are very technical, so we don't want you to go that way. We want to keep things very simple for your understanding from the practical point of view. For the course material, although it says skeleton, but the book is old. So although I wrote it and I uploaded it, but I found better books last night. So inshallah, and the books are available in PDF forms through our library. So I can share it with you, or you can access them through library directly, but I'll inshallah, I'll give it to you. But simulation is the second part, so it's not an urgent material, urgent issue. And then Arena, as you can imagine, what is Arena? Arena is the software that we'll be using. So there will be some tutorials I'll give you, and inshallah we'll look at that later. So in terms of quizzes, there will be two quizzes, one midterm, a project, and a final exam, typical distribution of marks. I hope you don't have any big question. You have done projects, so it will be almost the same. You can go with the same group if you like. You'll see, if you have seen already, you'll see two things: clustering, or you'll see simulation. This is part of extension of clustering and classification, but I'm not sure if we'll be able to do that, so I've put that at the end. Normally we do it after clustering, but simulation is very important. So, but we'll see if we could reach there. Any questions, queries so far, Anat? Any questions? If you can, okay, clear. Okay, so let me give you a flavor of what we are looking at. Or not, I didn't want this one. I wanted to see you something more nice. Let's see this one. Okay. Have you been, I'm sure you have been to different grocery stores like Panda, right? So
Yes.
we are, once you reach the cash counters, what do you face in certain times? Queues. I'm sure you have all, you've
Long
experienced
queues,
long queues, bad queues. Some stores are good at it, some stores are not very good at it. Simulation will be using queues. Queuing is a problem that is everywhere where you go. If you think of it, you go to hospitals, there are queues. If you go to banks, there are queues. Queue does not mean physically standing in a queue. Queue means standing behind people, right? So queuing is a huge business problem. So simulation deals with that queuing problem. So this is just one way. So in simulation, what we do, we try to model the word. I'm trying to use the same word as we saw. We'll try to model the same system, and then we'll try to, rather than physically change what is going on there and see if it works or not, we'll try to do it on computer. Does it look nice or not? So let me start it all over again so you can actually see. So simulation is about regenerating the reality. And so a person goes to a queue, randomly goes to a one. Now, because this one was busy, this is what you do, right? Because you're busy, so there's a queue here. So you go, isn't it what is going on, right? So as soon as you see a queue, you go to the other one, and then I'll try to accelerate it a little bit. So this people have, this is the very simple queue, you know. So there are situations like hospitals where you have multiple steps and many things. So people have especially in project, what you do is you're going to go to the real world, to banks, to hospitals, to things like that. You'll collect real data. This is not fake. You know what, the way people are coming in is actually coming, you know, from a real data. So real data, it's regenerating whatever is going on. Reality, then what I'll see is, okay, so this is the performance of this person. Like if I can train him, let's say, and improve the service rates, and you know, if I could add a third counter, what will be the effect on, you know, the queue lengths, the waiting times, and so many things. So this is just to give you a flavor. I hope you find it something attractive to learn for the course. Is this nice to look at, or it hasn't excited you for the course? Interesting, right? At least.
Yes, very interesting.
Yes, inshallah, it will be fun for you to do, because it's real thing, it's something real. Because once you go to, let's say, Al Jazeera hospital or this hospital, then you'll actually see that, you know, there's a problem and you're going to solve their problem. Of course, if they like to make use of it or not, but it's a real thing that inshallah will be doing. And you can see that it's very easy, because it's all visual programming. Means it's like drag and drop. So if I need to create something, I can just drag and drop like this, right? This is, by the way, a fake thing, a figure on top. So I'm just hiding my, it's called process actually. So it can even be visually very nice looking. I picked up a picture of, you know, a real counter, and then, you know, use it to simulate. But there's something very nice, and it's also nice looking as well as very powerful you know, very powerful tool. So let's just move on. So I hope, you know, you're looking forward to this course now. So end of marketing session. So inshallah, it will be exciting. So let's just move on to the course. Just one more time, you know. So do you have any question about any other thing about course outline? So the exam, the quiz dates, etc., are all mentioned there. So inshallah, we'll please make note of that, and inshallah, we'll try to stick to the schedule. So let us just move on. So first of all, we'll look at something called decision making as a component of problem solving. So while I mentioned that decisions are involved when you have choices, and choices are there because you're dealing with a problem. So problem solving itself, formal problem solving, involves few steps. So we'll see what problem solving means, and then, you know, what is the role of decision making, and then we'll try to position ourselves in this general concept about, you know, formal decision making and where this decision support stands. And you'll see some of the things that you're mentioning. It will be, inshallah, you'll see it being reflected there as well. So solution types and problem solving techniques, that's like decision making is the process of reaching a decision, and that decision is actually a solution you're giving it to your company. So solution and decision are just, you know, the two sides of the same coin. So once you make a decision, for example, the arena I'm showing you, maybe the solution or the decision you're suggesting is to add a third counter during peak hours. So that is the decision, which is to solve the problem, right? So solution and decisions are just two sides of the same coin. Then some issues that we needed to know about, you know, what are the key factors that we need to keep in mind while solving the problems. And then, because we are heading towards formal decision making, so one of the things that people use is DSS software. So DSS is a loose concept. Decision support systems are computer systems that help you make those decisions, but some people see it in one way, other people see it in a different way. So we'll inshallah look at that. Decision making levels, I already touched briefly upon it, so I'll inshallah talk more about it. You know, the common sense versus more structured decision making. I'll show you the most structured way, and you know, some of the other things. And then because in any DSS course, people talk about the software side. So typical DSS software available. So we'll just talk about some terminologies and so on. Not very important in my point of view, but still we needed to know, because if you go out into the companies, they'll be talking about GDSS and you know ESS and DSS. So we'll spend like 20 minutes to get to know those terminologies. So of course, you know, you'll be able to define what decision support is and some of the capabilities and you know some terminology and so on after the end of the course. So we'll start with problem solving. So business, you wanted to make decision because you're dealing with a problem. So there is always, you always start with a problem. And one of the things you'll see down there is what, you know, can you see my mouse? Let me turn on my, let me move this up. I have so many things on my screen. So just a second, let me. Why this taskbar is forced on my screen? So, okay, this is good. Okay, laser pointer, come back. Okay, so let's get back to problem. So we have a problem to solve. That's why and problem does not necessarily mean a bad thing. Problem means it could be a goal to achieve. It could be a genuine problem to solve. So one of the things we started off discussing, I just want you to connect to that, then we'll go up, is this thing. What is this thing? Choice. You remember our discussion a few minutes back on choices? No choice, no decision to make, right? It's a straightforward thing. And I told you that the more the choices, the more complex, you know, the decision making becomes. Now, when I asked you about what do we, you know, how do you make decisions, you started thinking more on more formal terms, and this is what is reflected, you know, in these first two terms. If I recall correctly, you were asking about, let me go back up in the chat. You were talking about existing knowledge, right? Like Dima said. And then some of you used the mic to say data and information. So this is all kind of hidden here. You wanted to know what is going on. So intelligence is about current situation. So everybody understand what is intelligence? So it's about data, it's about knowledge, it's about information. For what? For what? Know the existing situation very well, right? So you wanted to know about what is going on here. So it is about existing situation. I need to buy a mouse this time. You know, I kept on doing this in programming, but existing situation. Okay, so intelligence is about that. And then you started to what you call model it, the modeling part. Yeah, so I just showed you arena. So there are various ways to model it. And then this design, you know, general design, you know, you try to identify the choices you have. And then there's something missing here, but you need to pick a way to pick the right choice. So once the choice is picked as part of the whole decision process, you actually need to go and implement it. You have to make this work in the real world. Otherwise, there is no benefit. And then you have to see whether your implementation is done correctly or not. Now, the first three parts are what? The first three parts you can see here. The first three parts are, they make up what you call? Yeah, so we are concerned with these steps. Implementation is fine. But if you can do these steps well, then, of course, implementation is also very important, but this is like at the heart of the success. Okay. Now, because we wanted to do it more formally, let's try to look at it in a slightly different way, more elaborate way, but in a more formal way. So we start with intelligence phase. Intelligence phase again means what? Gathering what? Banath, gathering what?
Data information.
Data, information, anything we need to know about what is going on. So intelligence phase, and not only gathering, but now I'll add one more factor to it. And this is called analysis, analyzing the data, looking at it, through graphs, through charts, through any means that can give me more deeper insights. Okay, intelligence phase. Now, I'll just circle this thing up and I'll tell you that the first part, which is called clustering analysis, has a big role in this intelligence phase. Okay, everybody understand? We'll try to do a lot of analysis to get a lot of insights in terms of what is going on. You'll be amazed to see how difficult situations will be in real world where you'll not be able to see what is going on. So you cannot just walk in and say, okay, I understand what is going on. You have to gather a lot of data. You have to gather a lot of information. And then that gathering itself is not enough. You have to analyze that information through various means, few of them like using Excel and, graphs, charts, but more advanced techniques. One of the techniques we'll learn, and of course, to deal with a particular kind of scenario, we'll learn about using what you call cluster analysis or clustering analysis. It tells us a lot about certain kind of problems, not all kind of problems, okay, but it will be very helpful. And then you can see that, so this is intelligence. You can see that we are just trying to make it more elaborate. And then we go to design. So again, design and design phase and choices, but you see something more as compared to last diagram. Do you see that? Do you see there's something called feedback in there? Do you remember from HCI, there's something called feedback in your process? Interaction design or something process you must have studied?
Yes, from the user, the feedback.
From the user, from all other stakeholders, many things you discover there that not everything you're able to find until you reach decision phase and say, I did not collect that information, right? So you say, okay, we should have collected that particular information. So sometimes you have to loop. You have to make sure that, normally people go through one or two loops to make sure that they have the right information, and then they do the design. And then from design to choice, again, there could be loops. Now, one of the things you'll see here, very interesting, is another one which is called validate the model. Okay, so I'll take the example of this arena. I told you that we collected information. This is what you call customer arrival. There are ways customers arrive. So we went to Panda and we collected data between like peak hours between Maghrib and Isha. And then we whatever way we'll learn inshallah later, we collected the data. And then we are hoping that what happened? Unconnected exit point. Okay, sorry. I created something and okay, now it will work. So we are hoping that it is doing what is going on. Don't you think it's a big question? The whole model will scrap if it is not doing what is going on there and actually in Panda, right? Do you all agree with that? So once we are looking at it, we need to make sure that this is exactly going on what is going on typically in Panda between Maghrib and Isha, right? Do you all agree? Are you all able to get my point here? So I'm trying to model on my computer what is going on, but if it is not what is going on actually in Panda, then whatever I do after that will be a waste of time. Banath, can you give me a quick response? Do you all understand what I'm saying about this issue of making sure that whatever is going on my screen is the same as whatever is going on in the Panda? Now this is what you call validation. Normally you develop models on your screens so that you can work on them for making decisions, but you have to validate. So this validation link is making that thing happen. Okay, so everybody understand what this validation means? Checking whether what you're doing is actually going on in reality, so it matches with the reality or not. Okay, and then something called you have to make those choices. This is like debugging or something. We'll talk more about that. I'll not try to overcomplicate when simulation comes, but this is like, you'll try to just debug. In your software you have done debugging, right? So if it's not working, so because of some wrong coding, here we'll do coding, but you have seen it's not like typing coding. CA, where did I? Oh, CA. I wrote like Shad, when I wrote CA, I meant clustering analysis. I'm trying to refer back to two big areas that I mentioned. Where is that? You remember? I said there are two major areas we'll be touching in terms of decision making: clustering analysis and simulation. Okay. So CA was about clustering analysis. By CA I meant clustering analysis. So I said intelligence gathering. Here, clustering analysis has a big role here in terms of unearthing, what is going on in reality. Okay, so I was referring to that. And this part mostly will be focusing on simulation. So you can see the role of two things, and you can also understand why we are doing CA first and why we are doing simulation later. Although they can or may not be used together. But CA is about intelligence phase. That's why we are doing CA first, because it will help you understand what is going on here. And then simulation is more about design phase and design choices, and some of the other things. So we'll be looking at that. And of course, there are more things here that even your choices can still fail. So implement. If it fails, you go back and check, what you missed during your design process. If it is success, of course, take it to reality. Now, something that you talked, is that clear, Banat, from transition from here to here? There are a few additional elements. I added few elements from the simpler phase to the next phase. So if you could quickly just drop a word or two in the chat box when I ask, so I could have a better, because we're still not in the physical class. Hopefully we'll back, so we'll be in the class soon. So if you could just drop a word or two, it will be, I can see, whether you're following me or not. Okay. So you'll be able to see, can you all see transition between the simpler decision making to, with these additional steps? I hope so. So now, because intelligence phase is a big phase in making this decision happen, substantially and in the right direction. So let's just expand just this concept well. And by the way, when it comes to typical DSS, traditionally what people call DSS, this is normally, it talks about intelligence phase. But many people, as I told you, it is a loose definition. Many people actually talk about DSS not just in the intelligence phase, but in the decision phase as well. And there are shades. There are some DSS software that are heavily into intelligence phase. Then there are formal decision software which are a little bit into the decision phase. But then you can have people talking about serious decision making based decision support system. So we'll inshallah keep on talking about those things. Okay, now can you just give me a second, please? Okay, let's get back. So now we would like to talk a little bit more about intelligence phase. So what did we say about intelligence phase, Banat? We said it is about doing what? It is about collecting
data and doing analysis.
Collecting data and doing analysis. So you'll see don't you see the same thing here? This is like a more detailed view of that intelligence phase. Internal, external information. So you have to gather it. Okay, and then information you have to acquire. So this is like a database. This is like a company database, or it could be even social media these days. Sometimes you're gathering data from Twitter, sometimes you're gathering data from Facebook, sometimes you're getting data from different sources, but this is the data out there. This is the data out there. The data is there, but you have to acquire what you need. This phase is called what? Information acquisition. So you'll download this data from database into an Excel file, or you'll download, or you'll somehow extract information from Twitter into some notepads or Word file or some other form. And then once you have collected this data, it may be in different files. You have 5 different Excel files, different parts taken from different places, and and so on. So you have to what you call synthesize it. Synthesize. What's the meaning of the word synthesize in English? Synthesize means, what is the meaning of the word synthesize? In chemistry, you have done synthesis, right? Do you remember anything from chemistry, synthesis from your high school? Synthesis means putting things together, joining things together. It's like, you take things from different places and you join them together. So once you have acquired data, it's in bits and pieces. So this is like, in different files, so many different files, and even not only different files, but different formats. I'll take you to the course called Business Intelligence. Have you taken Business Intelligence already? I guess last time, right?
Yes.
Do you remember anything about data cleansing and data, all those concepts? I don't remember all those terms, but there's something called, there were some terms about data cleansing and cleaning. I don't know. Can you help me remind what was those? Anyone of you remember those things? Anyone remember? Anyone know?
Yes,
Don't
it's
know?
about filtering the data.
Yeah, but there were some terms about that, data. I forgot about it, but there was something about data cleansing and updating and many things. So, but this is that part. This is that business intelligence part. So I told you DSS is about business intelligence, business analytics, decision sciences. So that part is like, what you learn, you already learned data acquisition and synthesis. You have talked a lot about that in business analytics course. Oh, sorry, business intelligence course. So this all pertains to whatever you are learning there about gathering the data, even in what do you call that? Data warehouses, right? So you gather data from different data bases to data warehouses, and then you process, you clean, you update, whatever you do. And then this is where this is business intelligence. So we'll try to shift more, keep our focus more. We'll assume that a lot of data is already available to us, and we'll try to information sense making is about analysis. And this is where CA will kick in. What is the CA again, Shahad? Shahad, what is the CA? You asked this question, so I'm asking you again. Shahad, oh, cluster analysis, that's correct. We'll better call it clustering analysis. And then, of course, this part comes later, the decision, okay? So, Banat, so you all understand that decision making as part of the bigger business problem solving involves a lot of things, right? So validation, verification, intelligence gathering, information analysis, and then design and choice phase and implementation, and many things are there. So the formal decision making, as you can see, it involves more than common sense. Okay, so of course you can do that, but let us just talk. Let us just now focus. We know what is required. Imagine we have the intelligence with us, and we have all the things that we need. So we'll dig deeper into this design choice issue, not the implementation part. It will come later. The design choices and how we can make a decision. So when you making a decision, you mentioned about that. What is the first most important thing that you need to identify when you're making a decision? Yes, Pranat. So when you go buy something from the market. So you must have something in mind, right? What do you call that thing in the goal? Yes, sorry, Fatima, sorry, I missed that. Goal. Objective. That's what the word I wanted to hear. So decision, when you start your decision, you always start with what you call objectives. Go, whether you call it goals or objectives, let's stick to the term objectives, okay? Because in formal decision making, this term is very, very common. So they call it objectives to achieve. If there's no objective, there's no decision making. Now, can you tell me in business decision making, what are the most common, can you think of few most common objectives? Think at a very high level, think of your, think as typical business person.
Minimizing cost.
Yes, minimizing cost, maximizing profit, improving satisfaction, customer satisfaction, right? Like governments look to improve efficiency and so on, but these are like the typical objectives. There are always, yes, improve performance, that's correct, Laila. So these are what you call objectives. There are, in real world, many times you're just looking to minimize or maximize one of them, for example, minimize the cost or maximize the profit. But at the same time, it's very common that you face what you call multiple objectives. Okay, I wanted to buy a car, and which is the cheapest car in the market. So cost is one objective for me, but I wanted it very, very high performance. So how many objectives I have? So what's the first objective I mentioned? First objective I mentioned when I explain you this problem. Look, cost. I wanted to lower the cost, minimize the cost. What about the other objective? The other objective, Manat. I wanted to maximize the performance. Do you see a problem in these two objectives? Lowering cost, but at the same time maximizing the performance. Do you see any problem?
Yes, the two don't seem to align together. You need to have a middle ground.
Yeah, so this is fine. That's one way of looking at it, but I'm trying to show you that this is a challenge that you have to address. Of course, by addressing, like what Hajda says, looking what you call trade-off. The term for that is a trade-off. Okay, but at least you can have scenarios like this. Then one of the biggest things other than objectives you needed to know is what you call constraints. This is very, 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 very important. This is whenever you are making a business decision, I'm writing so many V's, is to know the constraints. What do you mean by constraints? Limits? Yes, Dima, limits. Limitations. For example, the car I wanted to buy must be available here in market, right? There can be a brand which is not available in Saudi Arabia, so I can't buy it. That's a limitation. I need you to know that these are the brands or the models. Yes, preventing points. I needed to know how far I can go. I'll tell you one limit. For example, when we are doing scheduling here in our college, no classes after 2 o'clock. That's what you call a constraint. We cannot start before 8:30. That's a constraint. The class cannot have more than 40 students, let's say. That's a constraint. We cannot have 3 classes in a row. That's a constraint. You understand everybody constraints? Constraints are the rules we have to follow in order to make decision. Now, because there are constraints, so you can see them as boundaries, like virtual boundaries. Now, if you have boundaries, what do you have inside? So if you can create that boundary from those limitations, what do you have inside? What do you have inside that boundary? Now, let me just go back. Think of from this diagram, what is the keyword that you'll find inside that boundary?
Choices.
Choices, great. You have choices within the boundary. And everything inside that boundary is within the choices available to you. Banat, do you all understand? How do we create those choices? So we needed to know my constraints. And once I know my constraints, I know my boundaries. So this space which contains all my choices is actually called what?
A solution
Solution
space.
space. It contains all possible choices. That's what you call a solution space. It's just a technical term. You know, from decision sciences, they don't call it choice, they call it solution. And from solution, they mathematically they call it. I shouldn't be, you know, using the mathematical terms here, but you know, all the choices together, they call it solution space. So how many solutions are you looking at here in this diagram? You know, this one. Can you name one solution that you're looking at? We have given name to those solutions.
A, the obvious solution.
Yeah, A, B, C, D. But how many solutions do you see here? Who said that? Sorry, I missed.
Betul. Yeah.
Yeah. Oh, sorry. I somehow this thing is not popping up. So what's your name again? Sorry.
Betul, doctor.
Okay. Yeah. So so some people are like Fatima and Shah are saying 6. Do you all agree that we have 6 choices in there?
I think 3.
Sorry, say that again.
3.
3 choices. Okay. 7. Zahra says 7. Okay. Now I want you to think again. I said something here in this diagram. I created the boundaries and I said everything inside is a choice. Which means what? How many choices here? A point is a choice. So this is a choice. This particular point is a solution. This point is a somehow imagine. You can imagine this point as a solution, whatever that solution is. Okay. So how many solutions you can have in there? I know I'm pushing you a little bit hard. So you have any idea? Not getting my point. 12, Shahad. Oh, Shahad is expanding. Okay, 12, Shahad. Let me add few points here. Do you think this point is inside the boundary? Now you should be able to answer. Do you think this point is inside my boundaries of constraints? Banat. I'm drawing a point here. It's a solution to my problem. You know, whatever that point means. But is this inside my boundary or not? Inside my solution space? Yes, Ajda? What about others? Yes, can you see this? Now, is this point inside my boundary? Again, I'm asking the same question. What about this point? What about this point? What about this point? What about this point? This point, sorry, points. I should be making points here. Now, can you tell me how many solutions we have here? Yeah, many, Zahra. That's correct. Many solutions. Many solutions are in there. A, B, C, D, E, F are just some of them. It does not meant to be telling you all of them. They are meant to be few of them. But now you have to understand this concept very well. Now I'll ask you again. What is this? Where does this boundary came from? Now let me ask you again because I removed everything. How did I draw this boundary?
From my constraint.
From your constraints. And I said that everything inside is what?
A choice.
A choice. So how many choices are in there?
Unlimited choices.
Unlimited choices in this case. Now do you remember the question I asked you that sometimes the number of choices could be so many that you cannot even think of all of them? So this is like a typical scenario. Now Fatima, I think, mentioned 7. Fatima, you mentioned 7 when I was asking this question earlier. I think it was Zahra, sorry, not Fatima. Fatima said 6. Zahra said 7. Did you include I in when you say 7, Zahra? No, can you turn on your mic?
Yes, doctor.
Why did you include I? I'm just curious about that. Because you see like A, B, C, D, F, G, H, I, so that's why I you included, right?
Yes.
Now we have to ask ourselves, is I a valid choice? Do you think I is a valid
No.
choice? Yeah, so it's not available to us. Why is it? Why it's not available to us?
Is it like an outlier point, kind of?
Outlier can
Outside the
still be a choice. Outlier still means an unusual, out-of-box solution, but the solution has to be still inside the boundary. Okay, I'll come to that outlier part in a second. Okay, but I is not a valid choice. Okay, now there are some choices are so in front of us, because there are many choices. At least you can imagine that there could be many choices in front of us. So one of them, few of them could be very obvious. Okay, and but does that mean they are good? Maybe, maybe not. We cannot tell. How can you? Okay, let's just move on to this point. So A, B, C are something very easy for us to see, but D, E, F are hard to identify as a choice. They are there, but as a planner you cannot see them. So these are called out-of-box solutions. I think you use outlier. So I'll just take it to those out of box solutions where you say where you have to think real hard. So yes, Lama, I think you were talking about I. It's out of constraints. Yeah, that was the point I was making. I is out of constraints. Okay, so which one is the best one here? Which one is the best here? A, B, C, D, E, F, E. So let's just stick to A, B, C, D, E. We know that they are all points are solutions, but let's stick to the one we have identified. So Fatima says A is the best one.
We
Okay,
need
you
to
have
compare between.
Yes, Hajda.
We need to compare between them
Okay,
to know what is the best one
based on what?
based on my objectives.
That's what I wanted to hear. Fatima, do you see this point here? A is based on what, Fatima, right? So we have to have a basis to choose which one is best. Now I'll give you some very interesting, again, I'll try to make use of this diagram to show you, how do we reach to the best choice. Imagine we have to minimize the cost, okay? The cost comes down, let's say, in this direction. Okay, I'm just telling you, I know I'm the experienced person to know. I know if we move in this direction, it will minimize my cost. Okay, so now tell me between A, B, C, and or let me simplify this a little bit more. Let me simplify because you may get confused. So I'll remove this again. So I'm saying that by going in this direction, the cost of your solution, the cost is minimized. This solution will, in this direction, the solution will give you minimum cost. So which one is the best solution, Manat, to you? You can see between A, B, C, D, E, and F, just between these. We are ignoring, all other option. So as you're going down, so C has a cost. Let's say C has a cost of $1,000. So as you're coming down, A may have not 1,000 but 900 reals. Okay, not 1,000. B is slightly above, so maybe 950. So now can you tell me which one seems to be giving you the least cost? Oh, I should be looking at the chat box. Sorry. Sorry, you're all giving me the answer. Yes, E, right? So now if I say my performance wise, I have to move in this direction, not the cost. So which one between A, B, C, D, E, and F, which one seems to be giving me the best performance? Okay, let me, I think the angular thing is confusing you. So let me remove, let me remove this direction. Let me just make this more obvious. Where is my pen? Too many things on the screen. Okay. So performance improves in this direction, horizontally this direction. So which one between A, B, C, D, and F? So which one is the best one? F, right? Lama says F, Fatima says F. What about others? You all agree? Hajda says F. Other Banat, do you all agree with that? We still have like 20 students. So others, what do others say? F, right? So you can see that it depends on the objective, right? So I think it was Shauq or Hajda. Hajda says that, we need to know the objective, and based on the objective, the thing changes. Now let me ask this question: which three were the obvious solutions when it comes to which three are the obvious solutions between all these six? Can somebody use the mic? You can see that A, B, and C are the obvious ones. So do you think either in terms of performance or in terms of cost, both objectives, whether we talk about the cost objective or in terms of performance, do you think obvious solutions are the best choices? Do you think obvious solutions are the best choices between A, B, and C? Obvious solutions doesn't seem to be not the best choices, right? So this is where the decision modeling and some of those advanced techniques come into play, because it might be coming from common sense, because this is obvious. I know that A is a solution as a common sense from my experience, but to be competitive in the market, if I choose A, I'll be less competitive. If I choose E, I'll be more competitive. Do you all understand where we are going in terms of decision? So decision support, making formal decision is about reaching the best decision. Okay. Now one small tip and then I'll stop. You can see that arrow keeps on going and it hits the bottom somewhere here. This is the lowest point. So actually E is itself not the best one. It is here which is the best one, and perhaps performance wise this is the best point at the boundary. So normally at the boundaries the best solutions are found at the boundary. So conceptually it is a little bit tricky, but that's the real tricky part. We have already covered the tricky part. If you understand this whole thing that I was discussing, if you understand this concept, then this is the toughest part in the whole course. Conceptually people get a little confused with this part. So let me just make sure that you all understand. So in order to make decision, what's the first thing we need, Banat? Quick feedbacks. No, we need to be very quick. Use your mics. The first thing we need?
Objectives.
And then we need?
Constraints.
And constraints create what we call?
Choices.
Boundaries.
Yeah, the choices or solution space. And in order, which choice is the best one? So we need to know what our objectives are, and based on the objectives we identify the best choice. Okay, so that's it. That's for this above part. This is the part we discussed, and of course this is this was the most technical part. Now do you all agree that it's a painful process? Can you all see the pain in it? I can hear from your voice that you're feeling a little unsettled. Do you all agree with that? Am I right in saying that you're all a little unsettled, that it seems like a bumpy road in front of us?
Yeah, and maybe when we implement it, it might get harder.
Yeah, but I can see it's fine, if you're feeling a little nervous, but it is a bumpy road, right? Because suddenly moving on from I can use my common sense to, and the doctor is pushing us to think of objectives and constraints and solution spaces. Yeah, it is going from informal to formal is a tricky road, right? I can admit that. But when the things get really competitive, you have to move. There's no other way, but companies need to move from common sense to more sophisticated techniques to beat the other company out of the market. And this is where you need to get more creative in order to find those unhidden solutions, not obvious solutions, which are more less obvious, but they are more creative out of the box. And of course, companies are being pushed by social and political decisions like new taxes. I need to lower my cost. Taxes are too much. People will not buy. They will push you to take those approach, right? Even international situations, like even Corona International, it's a big global problem. Now you have to think out of the box. You have to go to remain competitive in the market. You have to take that route. Technology, people are outperforming you, and you're pushed with time and everything, and you are facing the situation. This diagram is nothing but the same thing. These are constraints, and this is like your solution, and you just have to pick the right choice. Now I'll start with the good news. We are not covering the most technically challenging decision approach. But the bad news is the best solutions are obtained by the most sophisticated techniques. You can imagine that, right? There's a reason why there are more sophisticated techniques out there, because they're outperforming the simpler ones, right? You all understand what I'm saying here. So, but the good part is we are not covering this in this class, not in the sense of fine, we needed to learn those very complicated ones, but in the sense of learning, they are not easy to learn. But maybe at a later stage you would decide to go that way, because maybe you'll mature to graduate programs and so on. But in order to get the best solutions, you have to go to the most sophisticated technique, and that is called optimization modeling. Again, I'm using the word modeling. Optimization modeling is about using all your math. So what do you see here? What do you see the word here? Can you see the word here? A word familiar to you? Objectives. So you write your objectives in the form of math. That's it. And you say minimize my cost. So I can just write in more simpler language, I wanted to minimize my cost, right? And then what do you see here? What do you see here? Constraints. So I just defined my restrictions in the form of math. And bonds is nothing but another kinds of constraints, so it's also constraints, okay? And the decisions I have to take, these are decisions. The choices you are looking at, so these are like choices. This is like a choice. This is like a choice, I have to take. And some mathematical way to solve those equations, and it will take you to your best choice. So I know you're getting really nervous by all these explanation. Am I right or wrong? Banat, when you're all quiet, I don't know what you're thinking. Even if you're nervous, let me know that. Yes.
You do the optimization model with the programs, or mathematically you solve them?
Oh, I'm so happy, Hajda, to hear you. I thought you want to move away from this maths, but what you do is these equations cannot be solved by hand. So solving itself is a big area. It's a little overwhelming, fine, Shad, which is very, very natural, okay? But this is the hardest I've pushed you. The course is a little different as compared to programming. We went slow, then we went up. It is conceptually overwhelming, then it becomes easy, inshallah. Just to tell you that it will get softer, as we move along. But concept, these general, overall abstract concepts are a little hard to absorb. But then, that's the hardest part of the course. So let me answer, Hajda. So what do? There are two parts in optimization: creating the model and then solving the model. You create the model means you write the equations, okay? You understand, Ajda, what I'm saying? You create those, write those equations. And then there are people in mathematics who are experts in solving those equations. So people have then write programs for it, very sophisticated power programs. So we send these equations to this software. The equations are solved automatically by those software, and then this will give us the solution. Okay, you understand what I'm saying, how it is solved? So even if your knowledge about the math is not very high, still you can use optimization, but we need like a separate course for that. Still it's doable, it's very doable. But this part I must admit, it is like really hard. My work is, majority of the work is here model solve, but I work here in developing solution methods as well. But it is very hard. It's really at the cutting edge of what people are doing in terms of research. But you can solve by writing those equations and solving. So let me because Hajda has asked, so I'll take an excuse and just LP. Let me see. So let me show you a very simple quick example. Okay. So I have to buy two things. X1 number is the first two items. I needed to know how much X1 I have to buy. Let's say I'm manufacturing two things, so nuts and bolts. Okay, Ajda, can you see how am I doing? And I have to say subject to, or let me just write it. Or let me see if I can open already a saved program. I forgot how they write, because I generally don't use let me try writing x1 greater than equals to 10. Let me try to solve it and see if it allows me to solve it. Okay, so I say min, so I'm writing this, I'm not going into the details of it. What am I doing here? Okay, so I wrote those equations, I run it, and I have my results here, like my solution. They say don't buy anything. I wrote crap, so that's why it's telling me not to buy anything. But this is like the process. You write those equations, you let the software solve it, and it gives you that don't buy any X1, don't buy any X2. That's how it works. Hajda, do you understand how it works? In overall?
Yes, thank you, doctor.
Okay, now let's move on from the harder part. Let's try to simplify things further. There's another approach, and optimization is useless because it is difficult to handle. So we'll not be covering optimization in this class. We'll be moving on to a little softer side, which is called satisfying model. Satisfying model is, we do not go to those equations. We just use data, common sense, and we try to generate as many choices as possible, identify as many options as possible, using common sense and your experience and from your previous history and so on. And then we try to test this one and see whether it is satisfying our needs or not. And then we choose the one which is best. So it's like a hit and try. Much softer approach. You all agree? Much softer approach? Banat, do you all agree that it's a much softer approach? But does it guarantee the best choice? But does it guarantee the best choice? You can imagine that it does not guarantee the best choice, because it's like you just gather few choices and then you try it out. So it may take you to a better decision, but not the best decision. And then the least simplest way, even simpler way, and these are called heuristics. Heuristics means I cannot do even satisfying, so I'll just use my common sense. That's fine. It's a way to make decision, but this is where we started. We wanted to improve on that. Intuitive judgment, that's one way. Rule of thumb, my boss tells me that it works always. So that's like a rule of thumb. Educated guesses, I look at the data and this is what my hunch is, right? Stereotyping means everybody is doing it, so I'm doing it, right? And then profiling and so on. So these are the ways. But because heuristics is, we are trying to run away from heuristics, and we are trying to for the time being, inshallah, maybe at a later stage, we'd like to look at optimization, not in the course. I mean, if you like later in your careers. So we'll stick to simpler ones here, satisfying approach, satisfying model. Okay, Manat. So are you all exhausted, or do you want me to continue? Use your mics, use your... Hajda, you want me to stop?
No, I'm sure. Can we stop?
Oh, you're sure? Yes, that's what I'm asking. Yeah, I'm asking if you want me to stop, I can stop. Okay.
Yeah.
Now, Banat, if you're a little bit edgy, I also don't want you to get edgy about the course. Okay. So this was, I wanted to tell you that this was like the hardest part conceptually. So don't get nervous. Okay. This conceptually it is a difficult prospect, but not in terms of real applications. I showed you Arena, right? Arena seems nice, right? So you just need to go and drop things, and then you and then you so this part is easy. It just conceptually you need to understand where this whole thing is placed, where you're standing. So inshallah, things will be easy as we move along. Of course, there will be challenges. It's a 4th year course, but not conceptually. So inshallah, things will be fine. So inshallah, we'll stop now, and we'll continue from here. But because this part and this part, these two, especially these two, are the hardest part. I want you to conceptually understand these concepts that we learned today. So please read and listen to the lecture before coming, because I'll be asking questions about it. If you can answer me all these questions, I'll be really happy, and then the rest of the course will become much easier for us. Okay, everybody got that? Please make sure, do not come without listening back to especially these things, these two slides, our discussion on these 2 slides, and then inshallah rest will be fine. So if you do not have, we need 2 programs, Shahad. Shahad is asking a question. I don't know if you can see the chat box. Do we need programs? Yes, you'll be needing what you call, let me go out of PowerPoint slide. First thing you need is download this software called Arena. Arena, by the way, if you just write Arena, it will not work. Just write Arena simulation software. So you go to internet, and then you write Arena simulation download. You just have to, it is available free for academic use. Free for academic use means it has certain limitation, but it will be fine. So you just go there, and then Arena software in academics, and I mean you can figure out where you'll be able to download. And there must be somewhere where you can see that you can download Arena. Even if you just write download Arena simulation, it will take you to that page. Download Arena simulation. Now there's a help coming to me as well, simulation software, and then you'll be able to go to that page, download Arena simulation software. So you can download. The other software we need is called Orange software, which is real fun, and it works with Python. So you already have Python, and I have a hunch that with Anaconda installed, you'll have Orange already installed, but you can go and download this. And this is really nice. You'll inshallah, this is used for clustering, but these are the only two softwares we need. But again, it's visual programming. There's nothing like you have to like write codes or something. Even it's Python based, but everything is visual, drag and drop, and your model works like in a flash. Okay. Okay, Banat. So we should be stopping here. Is there any more question for you to ask?
Doctor?
Yes,
The
Sukaina.
next class will be in Canvas.
I can't hear you. Can you come again, please, Sukaina?
The next class will be in Canvas.
We are hoping that it is on campus next class, because the good part is you're 20, right? So alhamdulillah, I think one is missing, but because we are 20, so we don't have to split the class. So you'll be coming fully to the class. But what we have been told is next week we should be on campus, but they have also asked us to wait. So I'll confirm before the college confirms us that we'll be starting on campus, and then I'll confirm. Okay. Okay, so Ken. Okay.
Yes,
So
doctor. Thank you.
okay. Any other question, query? Okay. Thank you, Banat. I'm going to stop recording now, and inshallah we'll meet inshallah next week.